Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam. We have been preparing for ISS 2026 and we have covered one of the major topics of the syllabus, which is econometrics, which comes in descriptive paper 3 or statistics paper 3. Now we are moving forward with sampling techniques, and we have done the basics of sampling, simple random sampling with replacement and without replacement. And yesterday we did stratified random sampling basics. Today we'll move forward with stratified random sampling. I hope you all are doing it with us continuously. And consistency is the main thing that you should follow to in order to pass this exam. If you won't follow or if you skip the classes, then it will become very difficult for you to clear the exam. So I would suggest you all to keep on watching the videos regularly and keep on doing the work outside the video as well. So let us begin with today's lecture. So today's topic is allocations. Suppose we have a population. Now we know that population is heterogeneous in nature. All the units are not same. Different units are there. That is why we take strata. Suppose we take three stratas. Strata 1, strata 2 and strata 3. These are homogeneous in nature. All these strata are homogeneous in nature. Then what should be the sample size? Either we take, if we have to take sample from of size 6, either we can take 2 from here, 2 from here, 2 from here, which is equal sample, equal number of units from each stratum. Or we can say 3 from here, 1 from here and 2 from here. And likewise we can take any number of samples like that. But what should be the basics of selection of sample? So the question arises how the sample should be selected so that our our sample is precise or precision is there. Second is minimum cost is there. So as to minimize cost. And third is representation of each stratum. Representation of each stratum. To solve this purpose, we arrive to the topic allocations. Now, allocations is nothing but taking out units from each stratum with respect to some of the aspects, may it be size, may it be cost, may it be variability of the stratum. So, taking out those sample units in the sample and combining a sample from that. This is allocation. Now, there are four types of allocation. First one is simple equal allocation. What is equal allocation? That the sample size, which is Ni, should be N upon K, where I goes from 1 to small k. This is the equal allocation when we take out equal units from each stratum and then form a sample. So this is equal allocation. Second one is proportional allocation. Proportional allocation depends on the aspect of size of each stratum. Size of each stratum, suppose our stratum 1 has maximum size and stratum 2 has minimum size, but if we take out equal number of units from each stratum, then stratum 1 is not adequately represented and stratum 3 is more than what it should be represented. So proportional to the size of stratum, we will take out the sampling units from each stratum. So the size of the sample is directly proportional to the size of stratum. If we remove this proportionality sign, we'll put equal to and one constant Ni. Now this is equation 1. Summing over I goes from 1 to k, small ni is equals to lambda. Summing over I from 1 to k, capital Ni. Summing over I 1 to k, small ni is nothing but n, and capital Ni is nothing but capital N. This is our equation 2. So dividing 1 by 2, we will get Ni upon n is equals to lambda Ni upon lambda n. Your lambda gets cancelled and we are left with Ni is equals to capital Ni upon capital N into small n, which is nothing but Wi into small n, for all I goes from 1 to k. So this is the formula for the sample in proportional allocation. Now the third allocation is Neyman allocation. Now Neyman allocation depends on two factors. One is size and the other one is variability. Suppose stratum 1 has less variability within itself and stratum 2 has more variability within itself. So we'll take out the maximum number of units from the one which has more variability in order to reduce the variance. So we'll take out maximum units from stratum 2 and lesser number of units from stratum 1 in the sample. So here the sample size is directly proportional to the size of this stratum and the variability of the stratum. And removing this proportionality sign, we will add a constant. Let it be lambda. So it will be lambda NISI. Let it be equation number 1. Now equation number 2, for equation number 2, we'll again sum it from 1 to k, Ni is equals to lambda summation I goes from 1 to k Ni Si. This is nothing but small n and this is lambda summation I goes from 1 to k Ni Si. Let this be our equation number 2. So again dividing 1 by 2, we will get Ni upon small n is equals to lambda Ni Si upon lambda summation I goes from 1 to k Ni Si. Now lambda are cancelled again and we are left with Ni is equals to capital Ni into Si upon summation I goes from 1 to k capital Ni into Si multiplied by n for all I goes from 1 to k. This is the formula for sample, selecting the sample for according to the Neyman allocation. Now the fourth and most important allocation is optimum allocation. Optimum allocation depends on three factors: size, variability, and cost. Size, variability, and cost. It depends on three factors. So size and variability, I've told you. Now cost. We have to minimize the cost and the manpower as well, but here we are talking about only cost. So we have to minimize the cost in order to take the sample. If suppose we have to take a sample of a state have people who are educated, so that will be a very large sample or very large population, and the cost also will be increasing. So in order to minimize cost, we'll take a small sample and solve it after that. So there is a function of cost where C is equals to C naught plus summation I goes from 1 to K Ci Ni. This is the function that we'll use in this optimum allocation. Some things we have to mug up. So this is one of that. It will go back in the background of this. It will take time, and that is all useless for your syllabus. So I'm not going into the background. We'll directly write this, where capital C is total cost, C naught is overhead cost. What is overhead cost? The cost which was there from the starting. Suppose I am starting a business, and the overhead cost that I have put in the business is 5,000 rupees. So that will be our overhead cost. Then summation I goes from 1 to K Ci Ni is total cost of each stratum. Now, in order to minimize cost, we take Lagrange's function. So what is our Lagrange function? Phi of Ni is variance of y bar st plus lambda square c minus c naught, where lambda square is Lagrange's multiplier. This is the function of Lagrange's function. Now we know that variance of y bar st. We did it in yesterday's class, the derivation, which is nothing but summation I goes from 1 to k wi square 1 upon small ni minus 1 upon capital Ni si square. This we did in yesterday's class. If you have missed it, then you can re-watch that video, and you'll be clear with all the concepts of this thing. So putting the values here, we'll get phi Ni is equals to summation I goes from 1 to k wi square si square upon small ni plus lambda square. Now c minus c naught will be nothing but summation ci ni. So summation I goes from 1 to k ci ni minus summation I goes from 1 to k wi square si square upon capital Ni. This will be our function of lambda. Now we'll differentiate it with respect to Ni because we have to find the sample size. So that is why we are differentiating it with respect to Ni. So it will be nothing but wi square si square upon ni square minus sign plus lambda square ci, and we'll put this acts as a normal equation here, so we'll put equal to 0. So we will get wi square si square upon ni square is equals to lambda square ci. Now what is the value of ni here? Ni is wi Si upon lambda under root Ci. This is the value of Ni. Let us take this as equation number 1. Now since we have two variables, one is variable variance and the other one is cost. So we'll fix one of them and then minimize the other one. So there arises two cases. Case 1, we fix cost and minimize variance. We fix cost and minimize variance. So how to let us say that our fixed cost is C dash. C dash is nothing but the total cost of the stratum. I goes from 1 to k Ci Ni. Now here we can replace Ni from equation number 1. We'll get summation I goes from 1 to k Ci into Wi Si upon lambda under root Ci. So this will be nothing but 1 upon lambda summation I goes from 1 to k under root Ci Wi Si. Now the value of lambda from here we will get it as lambda is equals to 1 upon C dash summation I goes from 1 to k Wi Si under root Ci. This will be the value of lambda for all I goes from 1 to small k. Now we'll replace this lambda in equation 1. Let it be equation number 2. We'll replace lambda in equation number 1 and we'll get our value of Ni. So Ni is 1 upon lambda Wi Si upon under root Ci. Now replacing the value of lambda from that, we will get C dash upon summation I goes from 1 to k Wi Si under root Ci into Wi Si upon under root Ci. Now this Ci and this Ci cannot, or Wi and Si cannot be equated because here it is summation and they are without summation. So this will be the value of Ni in the case, the sample size in the case when cost is fixed, which is C dash, and our variance is to be minimized for all I goes from 1 to k. Now the second case arises. We fix variance and minimize cost. Now for the variance to be fixed, let us take V naught, which is nothing but variance of y bar st, which is summation I goes from 1 to k Wi square 1 upon small ni minus 1 upon capital Ni Si square. So we can write it as V naught plus summation I goes from 1 to k Wi square Si square upon capital Ni, which is nothing but summation I goes from 1 to k Wi square Si square upon small ni. Now we can replace again small ni from equation number 1. So we will get V naught plus summation I goes from 1 to k Wi square Si square upon capital Ni is equals to summation I goes from 1 to k Wi square Si square upon Wi Si into root Ci. Now here Wi Si and Wi Si square gets cancelled and there is also lambda. So the value of lambda comes out to be V naught plus summation I goes from 1 to k wi square si square upon capital Ni upon all of these values summation I goes from 1 to k wi under root ci. This will be the value of lambda, and this becomes our equation number 3 for all I goes from 1 to k. This becomes our equation number 3. Then again we will substitute equation number 3 in equation number 1. So our equation number 1 was Ni is equals to 1 upon lambda Wisi upon under root Ci. Substituting the value of 1 upon lambda here, we will get summation I goes from 1 to k Wisi under root Ci upon V naught plus summation I goes from 1 to k Wi square Si square upon Ni into Wisi upon under root Ci. Again, this cannot be cancelled because it is under summation and it is without summation. So this will be the value of our sample size in case of variance being fixed and cost is minimized, where variance being fixed is V naught. For all I goes from 1 to k. So this completes your topic of allocation. There were 4 allocations, and tomorrow in the next lecture we will complete one more allocation, which is proportional allocation, where cost is fixed and variance. Again, these two cases only: variance is minimized and variance is fixed and cost is minimized. So I hope you got all that we have done today in the class. If you still have any doubts, you can ask in comment section. And if you have doubt in something which has been done previously, then you can see our previous lecture videos in which I have explained everything very clearly. Thank you.